Alright, here are practice midterm exam questions, and I'm starting from 6 for this set. We'll see how far we can make it. This first question is relatively easy. If we're determining the difference between an observational study and an experiment, what we're really looking for is, did we simply observe and collect data through some sort of a survey or our observational study, or did we actually create a control group and try to do some sort of experiment on one part of the group and on the other group nothing, and then check to see what the differences were. So this description is, in a study of 356 men with a particular disease, the subjects were asked about their diet. Okay, so up into the comma, it could have gone either way, right? Because it could have said the subjects were given a placebo. Well, one half of the subjects were given a placebo, and the other half of the subjects were given some sort of a medicine that they're testing. But all it ended up saying was the subjects were asked about their diet. So observational. We didn't do any sort of an experiment. So see here, B. Okay, next one. Identify whether it's random, systematic, convenient, stratified, cluster. Okay, so really I would suggest you return to some animations for this one, and especially the reading of the definitions here. So to determine customer opinion of their safety features, Daimler Chrysler randomly selects 100 service centers during a certain week and surveys all customers visiting the service center. Okay, so weeks are natural clusters or stratifications of the year, right? And they select 100 service centers during certain weeks, and they survey all of them. So let's see, it's going to be either cluster or stratified. Now we got to read carefully. The key word here I think that they're trying to get us to focus on is all. Because when you're doing clustering, you break up your group by some sort of classifications, and then you take everything in one of those groups, one of those clusters. So I'm going to go with cluster here. Next. Okay, so we want to just determine if there is a simple random sample here. If you did not watch my other video, which wasn't necessary, I want to take you back to the Tools for Success page, where I've added in an animation that used to exist in previous statistics material. It's how random is sample. How random is random, and it talks about simple random sampling and just random sampling. Either way, I know that we did this in the homework also, so let's go ahead and read the example. You go ahead and pause it, read it, and then I'll get back to you. Alright, and I am going to say that this does result in a simple random sample, because it's essentially the hat pick, which is our classic example of a simple random sample, except for instead of using an actual hat, he's simulating it with a computer. But notice that he didn't list them 1 to 140,393 and then take every 8th one until he had 800, or every, kth number. He just had the computer generate 800 numbers between those two sets, and then he just took the voters associated with those numbers. So that is a simple random sample, and let me look at the choices. Well, there it is. The sample is a simple random sample because every sample of size 800 has the same chance of being selected randomly. The computer, if it's truly doing a randomization, it's any group of 800 could be picked from any other 800. Alright, back to observational studies as opposed to experiments. Remember how we talked about that question? So in observational study, a researcher plans to obtain data by examining the financial transactions of victims who perished in a hurricane. All right, I think it's pretty clear here. This is retrospective, right? So he's not asking the victims currently what their financial transactions are today. He's not setting up a cross-sectional study to look at them, you know. Anyway, so it's clear that it's since they've already passed, that that this is a retroactive study looking at the old data. Okay, and keep in mind on all these problems, when we answer them, we're answering and finding, you know, the correct choice for this problem, but we're thinking about what were the other options, and if the question was randomly generated, which it will be on the midterm, could I have gotten one that was related to one of the other options? So this question gives us the population of ages at inauguration of all presidents who had professions in the military. So I don't know if that's accurate, that there were only 1, 2, 3, 4, 5. I'm quite certain that that's not accurate. But if there were only 5, why does it not make sense to construct a histogram for this data set? Well, histograms come from frequency distributions, and those frequency distributions are supposed to summarize large sets of data where we typically create 5 to 20 class intervals, most commonly for ours 5 to 11. And we break up the data in these class intervals and then fill the intervals according to the frequencies that the data fall into. And clearly, if there are only 1, 2, 3, 4, 5, just double checking my count there, if there's only 5 numbers entirely, we're going to have a very, well, we're not going to be able to construct a frequency distribution with 5 to 20 and have them actually contain intervals. We could have them contain single points, but that's going to look ridiculous. So I'm just going to look for something that basically says it's too small. Oh, it's right there. With the data set so small, the true nature of the distribution cannot be seen with a histogram. Right. Okay, so I'm going to take a break here at about 7.5 minutes, and I'll do the next.